Right. Here we go. Okay. Good day. Glad to be with you today, although with a remote recording. Unfortunately, I was not able to attend today's session, but I wanted to get my recording out there. My name is Kevin Junck, and I work in the radiology department at UAB Health System, University of Alabama at Birmingham. And I'm going to talk a little bit today about some of the infrastructure or the background items that you might want to think about for artificial intelligence applications at your institution. I've been working in medical physics and then informatics for the last 25 years here at UAB, so I deal with all of the PACS systems, radiology information systems, electronic medical record, all of the interfaces that connect these things together. And more recently, with some of the implementations of artificial intelligence applications that we've done here at UAB Health System. So I'm going to talk a little bit about kind of the not so sexy stuff, the background infrastructure stuff that kind of helps to make everything run and hopefully keep it running smoothly. And I'm going to bring up a number of points today that hopefully you might want to think about a little bit as you're moving forward with learning about artificial intelligence. I hope that Jordan will collect if there's any questions at the end of the session today, and I will try to get back maybe an email blast to the group with answers. So please hold those and let Jordan know, and he can get them shipped to me, and I'll try and get them turned around back to all of you. So first off, disclosures, no relevant conflicts of interest that I need to disclose here in terms of financial or otherwise. And what we want to talk about today really is artificial intelligence applications. And now these, as you've been learning in the beginning section of the class that I think was last fall, and talking about in this intermediate level class, artificial intelligence applications are going to come in throughout the whole radiology imaging workflow chain. The big thing that gets the buzz and that we see on the news and we see articles about in antmini.com and at all the conferences are, hey, I've got this AI algorithm and I've trained it on these sorts of images and it can detect this particular clinical finding as well as a radiologist. And that's what gets all the buzz. But really, artificial intelligence applications can be in use throughout the whole pipeline. So for example, starting with source images, we've been recently working on a project here at UAB that involves looking at MR acquisition time and being able to reduce parameters on MR sequences to make noisier images, but we can acquire them a lot faster. And then in post-processing with artificial intelligence, clean up the noise, improve the spatial resolution to make them look pretty again. So we have good-looking, high-quality diagnostic images that make the clinicians and the radiologists happy, but reduce maybe by 20, 30% the amount of time that patient has to lay on the table in the MR scanner. So you can see artificial intelligence coming into play at the very beginning with the generation of the images. There's artificial intelligence systems that look at, even before that, the scheduling process and the ordering process to maybe help get the right exam ordered in the first place and to get the patient scheduled as quickly and promptly as possible. So there's, even before we get to images, there's artificial intelligence applications being applied in the real world. Image review. Now, this is the thing that, like I said, gets kind of a lot more of the buzz. Basically, images go to a system, it looks for something, it might notify you, hey, I think that there's this particular finding on this type of image. And maybe you want to triage it, bump it up in your work list and look at it next amongst those 10 CT exams that you've got to read. Hey, let's flag this one so that it becomes the hot one to look at next. Image analysis, segmentation of images, a big area of artificial intelligence applications. And even at the end of the chain with reporting, we've done a project here at UAB that uses artificial intelligence to look at the text of the report, all of your findings, and come up with a general conclusion or impression statement at the end, kind of wrap everything up by looking at your report text. So artificial intelligence can be applied throughout the whole imaging workflow chain. So we want to keep that in mind. So what we're going to talk about today are kind of some other infrastructure pieces that we need to accommodate deployment of these algorithms. Everybody is busy at the institution. You know, we don't have time to reinvent the wheel for each application. So a little bit of maybe forethought and looking ahead, proactive, to be able to figure out what do we need in place to develop not only this one particular algorithm that I want to implement to solve this problem, but let's look ahead and do things in a smart way so that we'll be able to utilize other things down the road. Would not reinvent the wheel each and every time for each and every application. It just adds to the cost and the time to get something spun up and moving forward. And one of the big things that you've got to think about when you're looking at some particular system is, how is this going to incorporate with my existing workflow, my existing systems? I've got an EMR where the physicians are ordering exams, and where at the end of the day, all my information ends back up in that system. We've got the modalities themselves. We've got PACS, voice recognition. You may have some type of workflow management software in your institution that helps you to guide what's the next exam to read, or that may be rolled into your PACS. You know, different places do things slightly differently. But whatever your current workflow is today, how is this new application going to fit into it? It's got to work in seamlessly with your existing systems. And that's a big part of what we're going to talk about today. Okay, first off, servers. Well, most any type of AI project is going to require one or more servers. We've worked on a number of these projects here, and it's like each system kind of requires their own server. Virtual server, maybe hardware sitting on site. Maybe it's running the algorithm that's doing your processing, or if you're using commercial applications from other companies, it'll be an edge server. It's going to sit on your network and serve as kind of a gateway between your systems, the PACS, the voice recognition systems, the imaging modalities, and the vendor's cloud, where they're going to do maybe their processing of your images. Okay. Most of the time, these servers are kind of like one application. You know, on your Office PC, you might be able to run, you know, Microsoft Office to do various things. You might have, you know, several different web browsers that you can use to surf the web. And you can do lots of different things on it's a general appliance that you can do lots of different things on, load lots of different software on. Most of these servers, it's pretty much a one-off system. Each vendor assumes they are the only game in town. Their software is going to be on the system, and nobody else's is going to be on there. So that you don't run into any conflicts between software packages. Each server kind of assumes that it's got its own special reason for life. It's got its own software on it. And as long as it can run on its own, it's happy. So you can see that if you're going to run a number of different AI algorithms, or if you're going to run a number of different systems, you're going to have a bunch of different servers hanging around. So one of the things you got to, as you go into each and every project, we sit down and we look at the specifications from the company that we're dealing with. What type of operating system needs to be put onto this particular server? How much disk space? Is it going to be holding images? Is it going to be passing images through? Is it okay to have multiple drives? Our IT department likes to have a C drive on a server, and all it has is the operating system on it. And then they create a separate drive, a D drive, which maybe has space for the vendor to place their software, storage space for images that are coming or going, who knows what, but they want to keep things separated. The C drive just has the operating system. The D drive has all the vendor specific stuff. Well, some vendors are okay with that. And other vendors say, no, we haven't really developed our software that way. We need access to put our software onto the C drive. So these are the sorts of things you kind of need to think about, and you got to negotiate between your IT department and between the vendor. Number and speed of CPUs, if you're using graphical processing units on your server, and all this is going to tie into how much is the cost of the server, which can become a pretty substantial part of your whole project budget. So, I mean, again, it's something to kind of factor in, both not only from the monetary side, but also time-wise, because these servers don't just automatically appear. Before a AI application system gets dropped into my lap as the technical guy who's going to implement things, there's been a whole pipeline of things going on, like the whole legal and contractual piece, the actual purchasing, reviews with our IT security department. So literally it can be months and months and months before a project gets to the point where I get my hands on it and can actually do something and implement it. Okay, so getting servers set up, feeding into that whole thing. So one of the things, if you're going to be involved in AI implementation at your facility, get to know your IT department and their processes. Okay, they're going to be instrumental in approving things and getting things set up, and you've got to know what their processes are and what the sort of lead time is for a server to be set up. I've seen a number of physicians get aggravated because they expect that, well, I've decided we're going to use this software, let's get it going. Things don't move that fast, and it's going to take a lot of people to get these things set up. So lead time for the server to be set up, time to work with the vendor to implement their software on it. Even like I said, before we get to that point, security review for data flow. We've got images that have PHI on them. We got to make sure things are handled appropriately and securely, especially if they're going off site. Does the gateway de-identify images before they go to the cloud and then re-identify them when the images come back from the cloud? Or is that PHI actually leaving our institution and going out there into the cloud? Got to understand the whole flow and understand what the problems are. Within an institution, network firewalls, that's a big issue. We want to be able to, again, in the name of security, we've got to keep things kind of tight. So our MR scanner can't just talk to anybody in the institution. That's a good thing. If somebody were to break into the network at UAB, you don't want them to have carte blanche access to everything at the whole institution. So we build kind of little separate islands of equipment. The servers are on one island, and the MR scanners at our outpatient facility are on a separate island. And we've got to open up a path between those two to talk to each other. That's what the firewalls are within the institution. The idea, again, being like a firewall. If you have a fire in one area, the fire can't quickly get through to another portion and create havoc there. So we want to be able to kind of keep things walled off. That helps to make things more secure, but it also leads to a little bit of overhead in terms of when we're getting things set up, we've got to think through, okay, the MR scanner needs to talk to the edge server, which needs to talk to the cloud. Maybe once the images are processed, we're going to have them sent to the PACS. So again, I got to be able to talk from the edge server to the PACS. And just because I can talk from point A to point B doesn't mean I can talk from point B to point C. So we've got to think through that whole flow and get everything lined up so that everybody can talk with each other. As these things become important, we got to have a backup plan. What happens if that edge server goes down? Are we dead in the water? Can we have another server sitting there in standby mode that we can use if the primary server goes down? So a number of things, if this really works, and it becomes a dedicated part of your operations, you've got to think through, okay, that's great. Everything works wonderful. What happens when it doesn't work wonderful? What happens when this piece goes down, or this piece in the chain goes down, or this piece goes down? Got to have a backup plan for all those sorts of things. So thinking about that up front, maybe in the initial implementation, in the initial pilot phase, you're trying something out, that's not so important. But when things go into production and you're really dependent upon that system, you got to circle back and think through, okay, what's going to happen when things are not behaving well? How am I going to handle all that and keep everyone from having a panic attack about it? Okay. All right, so let's talk about a couple of other items, a little bit more specific now within the radiology sphere. So I'm talking here about in general an MR scanner and an image flow, thinking through where do these images need to go to various systems downstream. Maybe it's pretty simple. An MR scanner generates a bunch of MR images, and all I got is one place to send them to. I send them to my PACS, everybody looks at the images, and we're all good to go. Okay, well, now I've got some new artificial intelligence application, and I want to be able to send the images to it for, like we were talking about earlier, segmentation, or maybe it's going to do some type of post-processing, or it's going to analyze those images looking for some type of clinical finding, what have you. But the images have got to get to there. Well, how are they going to get to there? And in MR images, I want to get my MR images to my new server. It's running this cool AI application. Well, how do I do that? Well, I can set up the MR scanner to know that destination. In DICOM, there's typically 3 particular items that you need to know to send images to another. You need to know the application entity title. That's kind of the name that other system is going to advertise, the actual IP address where that server is located, and what port number. We can talk on various different ports. So those are kind of the 3 common pieces that you need to know to get images from point A to point B. So, okay, so now I got to go in and I've got this new server. It's going to, and we've worked with the vendor. It's running the software. I've got to get images from the scanner to the server. Well, some MR scanners, you can just sit down and configure the MR scanner yourself. Sometimes you need to make a service call to the vendor to get in and access and set these things up. Okay. Different modality vendors behave differently. I know one vendor that we have here at UAB, we can do pretty much everything ourselves. Another vendor, we can't do anything. We have to call them 1-800 vendor, and they'll access the system and they'll do it for you. You give them all the information and they'll get to it when they get to it, because they're busy folks too. So again, it's kind of a pain. If I have a lot of MR scanners, I've got to do this on all the MR scanners at my institution. I've also got to think through, okay, am I going to rely on my technologists? How are they going to send these images? Are they going to manually send the images at the end of each case? Well, they're busy getting the patient off of the table, taking out the IV if there was contrast. They're dealing with a whole bunch of stuff as well. It'd be kind of nice to automatically send the images. So can I do that with my MR scanner? What if I only want some of the images? This particular AI algorithm that I have looks at brain images, brain MR images. It doesn't care anything about abdomen exams or hip exams or knee exams or anything else. So thinking through how you're going to do your image flow is important, and keeping in mind, okay, this is my first AI application, but what happens when I've got my second, or I've got my third, or I've got my fourth application, and maybe they're from different vendors. Maybe I'm not using all from one platform. So thinking through with a little bit of forethought how I'm going to get images to go through this whole system is important, because I don't want to have to reinvent the wheel all the time. I don't want to have to come back and do multiple service calls to the vendor, adding in a server each time we go. Okay. So maybe and this is what we've done here at UAB, maybe we set up an intermediary layer, some type of a DICOM image router. So the router receives all the images, and then the brains are kind of there at the router. It can forward those images to application A, application B, application C, and I can usually configure that pretty quickly and pretty simply. So this is what we've done here, especially with CT exams actually at UAB. CT exams from the scanner, they go straight to PACS because we want to get them into PACS as quickly and efficiently as possible. So the modality sends the CT images to PACS, but then it also sends the CT images to this DICOM image router. And from there, I can send them to whatever application. Setting up a new flow at that DICOM image router only takes a few minutes. I don't have to call the vendor to add in a new destination. I go to my image router, I add in that information, I tell it what types of exams I want, and it's generally pretty much no muss, no fuss, and within a few minutes, I can get things going. Now, there's commercial products that are available for these DICOM image routers. We utilize one here at UAB from a company. There's also open source software I've used in the past, a software package called Mirth. There have been occasionally in the past live lab sessions at RSNA talking about this software, and it basically can be configured like a DICOM image router and also handle HL7 messages. Very powerful little open source software package that's pretty handy. But if you're going to be doing multiple applications, you're going to be sending images from the scanner to multiple points. Sometimes it makes sense not to do that at the modality, but to add this intermediary layer in and be able to push the images around where I want them to go. So now my image flow might be that my MR scanner generates those pretty MR images, and I have the images go to PACS. And I also have the images go to the router because then I can send it to multiple applications. Now, these might be artificial intelligence applications. They might be some type of post-processing system. There might be some type of little mini PACS system. I was thinking earlier today, just off the top of my head, I could name about 10 different systems besides our main production PACS that we send various images to for various reasons, various applications. Some of them AI, some of them post-processing, some of them little mini PACS things that solve particular little niche problems. So the router gives us the flexibility to be able to shoot those images around to different applications. And now, of course, again, like we talked about earlier, if this becomes, a high-end production thing, I need to have maybe a couple copies of the router around, because if one of them goes down, then all my downstream applications ain't going to get any images, and they're not going to be happy. So you got to, again, think through your backup plans, and it adds a little bit of overhead there, but it gives you a lot of flexibility. And this is something we've used successfully here at UAB for a number of years. Okay. Now, let's talk about integration a little bit. And I'm going to use one particular example here of an AI software package that we've implemented a few years ago here at UAB. And AI applications will often come with their own software for notification and viewing. So this is one of those applications where I send it the CT images, it scans the CT images and looks for particular clinical findings. It's going to kick back a notification to the radiologist saying, hey, I see something on this. I think you might want to look at it too, and maybe bump it up the priority of your work list of all the exams you've got to take a look at. Okay, so this particular application, when it's found something, it wants to alert you. So it provides a little banner. This thing kind of pops out the side of the square. It looks kind of like it's sticking its tongue out, I guess, for lack of a better analogy. But it tries to get your attention and says, hey, I found something. You might want to take a look at this too. It has a nice little viewer inside of it. And it shows you the images. It shows you can click on a button and it shows you a heat map saying, here's really what I was focused on. And here's what I think you need to take a look at. I see an intracranial hemorrhage. You might want to take a look at that. That might be important in the care of this particular patient. Okay, so they've got nice viewers. The people who developed this software have done good work in displaying all this sort of stuff. That's all well and good. Okay, but I've got a lot of other stuff going on. I've got my PACS that I'm supposed to be reading these exams on. I got my voice recognition system. I need to do my report in it. I'm keeping an eye on the markets and what the news and what's going on. I got my email. People are sending me stuff. I got meetings popping up all over the place. So this can become very frustrating. And if I'm supposed to watch out for that little orange box, it quickly becomes a game of like the children's book, Where's Waldo? Okay, I've got so much stuff going on. I need this tied together. I need this integrated into my normal workflow. I'm usually looking at the PACS and looking at those images. So show me what I need there, not out here on this other little separate widget that's floating around somewhere on my desktop and I got to keep track of. Okay. So integration, most PACS have some type of API, application programmer interface. This allows different applications to pass information and commands back and forth from one to the other. We're already familiar with that. For the most part, the PACS is tied into the voice recognition system. When you open up Joe Smith's exam on the PACS talks to the voice recognition system and says, hey, he or she's getting ready to read Joe Smith's CT exam. Here's the medical record number. Here's the accession number, whatever it passes over. So the voice recognition system can open up and get ready for you to do your report. Okay. So understand what methods you have to be able to tie these pieces together. Okay. Between the PACS, between the voice recognition system, what have you, because that's where the benefit really comes in when I can feed this into my normal workflow. So one of the big successes that we had with this particular AI algorithm was at the outset, they didn't really have the software available to tie this into PACS. Eventually they got it, and that really kind of helped the workflow along. So now if I'm looking at the little widget box and see it stick its tongue out and tell me about something, I can go up there and click on that view in PACS, and it will talk to my PACS system and open up that exam automatically for me. I don't have to look at the widget and say, okay, this is Tom Jones, and then I got to go find over here Tom Jones in my list and open up Tom Jones. Okay, I want to have those two talk to each other. So all I have to do is click a button and boom, it's going to open up in the other system. Likewise, in my PACS system or in my workflow manager system, I want to have some indication that Tom Jones has some type of finding, and maybe I should look at it next in the list. So in this lower portion right here, this is our workflow manager. And one of the other items that we worked on was if the AI algorithm does see something, this big bright red box pops up in my workflow manager, and I can see I've got 10 CTs to read, and this one's got the big red AI button on it. Let me click on the read button and take a look at that one next and see what it found, what it had to say about this case. So having these tie-ins between the systems, this integration between the systems, it sounds simple. It sounds like it should just be a piece of cake, but if you don't have it, it becomes a real mess and a real big hurry. So you got to understand what the capabilities are of all your other subsystems, okay? The voice recognition system, the EMR, the PACS, whatever the AI algorithm needs to be able to talk to, can it talk to it? And does it fit in seamlessly with the other system? Okay, one final other thing to think about and to kind of keep an eye on is access. So for example, user access to applications and images. At most institutions, you're going to have Active Directory groups. So these are groups of users that can be granted access to an application. It allows you to have one username and password that you use to get into the system, but then you only have rights and privileges to those groups that you're a part of. For example, in our AI algorithm, one of the questions came up, well, we're an academic teaching facility, and the first year, second year, third year residents, maybe we don't want them to see that AI flag. That's going to tip them off that there's some finding in there. We want them to find it on their own. And so maybe the fourth years and the fellows and the attendings should be the only people who have access. So for that particular application, we had a separate group. And this is like a whole list of a bunch of different groups in our system, but we created one separate group that we could put those users in. They would have access to that application. For everybody else who logged into the PACS workstation, if you didn't have access to it, you wouldn't see that application come up. Okay, so access is another thing to think about. Who needs to be able to view this and maybe who shouldn't view this. Another item to think about and to how to tie in your various systems together. Okay, so in conclusion, basically, I want to say there's always a lot of neat new applications that are out there. But really, if you think through what the infrastructure needs are and how you can expand your infrastructure to handle those things, it's going to go a long ways to make everyone happy and to make your implementations go a lot smoother and a lot more straightforward. Thank you a lot for your time and attention today. I hope this has been helpful. Have a good day.